Welcome to The Explainer. Today, we're doing a deep technical teardown of CineGraph. If you're a senior Unity programmer, you already know that managing cinematic sequences can often turn into a massive labyrinth of spaghetti code and incredibly fragile scene references. Well, today, we are going to look at how this tool steps in as a true enterprise-grade architectural solution. It's literally a complete reinvention of how we structure narrative in Engine. Get ready to leave that spaghetti code behind for good.
Okay, let's dive right into this. Here is our technical roadmap for today. First, we'll say goodbye to rigid timelines. Then, we'll look at the data and context architecture, followed by string keys and the global registry. After that, we'll tackle performance and safe skips, decoupled logic using the event bus, and finally, extensibility and debugging. Let's get to it.
Section 1. Goodbye to the rigid timeline, and how we're fixing the absolute biggest headaches in Unity cinematics.
We've all been there, right? Fighting against inflexible timeline tracks or writing endless manual coroutines to manage simple camera movements. So let me ask you this directly. How many times has a broken reference completely ruined your cinematic? Picture this. You spend hours meticulously dragging game objects into a native timeline. Everything works flawlessly on level 1. Then, you try to reuse that exact same cinematic on level 2. Or maybe your character is spawned dynamically, and boom, suddenly everything breaks. Your console is just a sea of null reference errors. CineGraph is built specifically to eradicate this exact problem from the root.
Moving on to Section 2, Architecture, Data, and Context. This is the paradigm shift for achieving total scene independence.
Now, what's really interesting about this is the core design philosophy. On one side, we have the cinematic sequence. This is a pure data container, saved directly in your project as a scriptable object. It defines the flow and the variables, but here's the kicker. It has zero direct references to the scene. It's completely agnostic. On the other side, when you actually hit play, the engine creates a cinematic context. This is a temporary runtime instance that handles dependency injection and creates an exact, isolated copy of your local variables in memory. This strict separation guarantees that variables never corrupt your original file, and it massively improves your code's modularity. You can literally run the same cinematic on 10 different NPCs at the exact same time without a single data collision. It's brilliant.
Section 3. String keys and the global registry. Let's look at this hybrid actor system. So if we've completely abandoned direct references in our scriptable objects, how do the nodes actually know what to move? Well, instead of rigid references, we use identifiers or string keys, like main camera or boss. During execution, the context first checks the local registry of the sequence player in your current scene. If it doesn't find that identifier there, it smartly falls back to the global cinematic actor registry. Because of this strict priority order, your cinematic graph becomes 100% independent of the scene. Any senior developer is going to immediately see the immense value here. It allows for truly infinite reusability of any narrative script you write.
And this brilliantly illustrates the elegance of the whole system, the wait for actor node. Imagine your scene is loading additively, or a spawner generates the boss a few seconds after the level actually starts. With traditional systems, syncing this up without throwing reference errors is an absolute timing nightmare. But with this node, the flow simply pauses asynchronously. It just waits silently. The exact millisecond the instantiated actor self-registers globally, the node completes and the cinematic continues flawlessly. It is a clean, professional, and absolutely bulletproof solution.
Section 4. Performance and safe skips. We're talking about bulletproof memory and state management here.
Let's talk about performance, because CineGraph completely eliminates the classic heavy update method. In traditional visual systems, you've got these massive update methods checking game states every single frame, just devouring valuable CPU cycles. CineGraph, on the other hand, is extremely garbage collection friendly. It executes sequences node by firing native Unity coroutines. When a node finishes, it simply tells the engine where to go next. And the best part? If the game pauses or the node is waiting, the coroutine just rests idly without consuming any performance overhead. It's a radical optimization of your system resources.
But here's the real mic drop feature, the ultimate solution to cinematic skipping. When a player hits that skip button, the system doesn't just stop the animation and hope for the best. First, it immediately stops all active coroutines. Second, and this is spectacular, it invokes the apply final state method mathematically for all remaining nodes in a single frame. It literally calculates the exact final state. Third, it fires the on-skipped events. This means if halfway through a cinematic, a node was supposed to give a key to the player, that variable gets updated instantly. Your game state remains mathematically perfect and consistent. No more broken quests, no more soft locks, no more characters floating in midair.
Section 5. Decoupled logic using the event bus, keeping your gameplay entirely separate from your cutscenes.
Traditionally, you'd tightly couple your logic using direct Unity events, dragging references from your quest manager directly into the cinematic in the scene hierarchy. The risk of breaking this, or just causing massive level bloat, is sky high. CineGraph uses a near-zero risk approach, the cinematic event bus. A node in your graph simply fires a string identifier, like boss defeated. And from your own C# scripts, anywhere in your codebase, you just subscribe to that string. The cinematic knows absolutely nothing about your quest manager, and your manager needs zero references from the cinematic. It is the ultimate expression of clean, completely decoupled code.
Let's move to Section 6 and see how this builds a true developer's playground with extensibility and debugging. In a real production environment, you need fast tools, and CineGraph packs an enterprise-grade debugging suite that is pure gold for QA. You've got the Variable Watcher for live monitoring and editing of local variables right in play mode. That's absolutely crucial for forcing story branches without having to play through the whole level. You have a registry debug window showing your live actor list with a one-click ping straight to the hierarchy. And you get a history log that tracks the exact execution times of the last 50 nodes down to the millisecond. This is going to save you so much time during complex level design and testing.
And if you need the cinematics to interact with a highly specific custom system in your game, extending the API is ridiculously easy. You just create a C# class that inherits from cinematic node, override the execute coroutine, and define what happens and apply final state. You don't have to program any tedious visual editors. The system uses C# reflection to automatically draw it right onto the Unity node canvas. You're up and running in minutes, not hours.
So the crucial point is this. We've seen the massive efficiency of coroutines, the mathematical safety of sequence skipping, the powerful decoupling through string keys, and the huge architectural benefit of isolating data in scriptable objects. If you're a senior programmer and your current cinematics aren't modular, aren't data-driven, and don't fiercely protect your game state, are you truly engineering your game's narrative, or are you just putting out fires every time a player changes levels? Consider how this architecture can elevate your codebase and the stability of your entire project. It really is time to make the jump to an enterprise-grade solution.